Hello, welcome to the course of IPv6. So today we are going to discuss about the extension header and the prefix notation in IPv6. So as in previous class we have discussed about the IPv6 header. So in this class we are going to discuss about the extension headers and its prefix notation. So let's first start with the extension headers. So here the extension headers are added to IP packets to give them a greater functionality. So it is added with a base header, and these are the extension headers that we can add to the IP address, like hop by hop option, source routing, fragmentation, authentication, encapsulating security payload, and the destination option. So let's start with discussing about this one by one. The first one is hop by hop option. So here the hop by hop option specifies delivery parameters at each hop on the path to the destination host. It means it is telling the destination host about the number of routers that are visited by the packet as they are traveling from source to the destination. So they are giving about the information about all the routers that is visited by the packet. So it is identified by the value 0 in IPv6 header next header field. It means if the next header field have the value 0, then it means it has extension header known as hop by hop option, and it is of 8 byte long. Next part is destination option. So here the destination option header has the value of 60 in header's next header field. It means if the next header fields contain the value 60, then it will defining the destination option with as the extension header. So it is used to specify packet delivery parameters for either intermediate nodes or the final destination. So here it also defining the packet delivery parameters like the source address or the destination address and the number of hop count. So it is delivering all the packet information to the intermediate node as well as to the final destination. Next we are going to discuss about the source routing. So here the source routing header have the value 43. So here if the next header fields have the value 43, then it is adding a source routing as extension header. So it specifies a source route which is consisting of intermediate nodes traveled by packet on its path to the final destination. So here the source route is specifying the number of intermediate nodes that is traveled by the packet from source to the destination. And next header is fragmentation header. So here the fragmentation header is used for IPv6 fragmentation and reassembling services. If the value of next header field is 44, then it means the extension header is the fragmentation header that is added with the IPv6 packet. So fragmentation header is used when a packet to be sent is larger than the maximum transmission unit a path can hold. So here then the sending node splits the packet into the fragmentation. So the packets are splitted into the small groups, and the fragmentation extension header carries the information that is necessary to reassemble the original packet at the destination node. So these are the functions that is performed by the fragmentation header. By first of all, it will fragment the packets into small groups, and then it will pass the information to the destination how to reassemble these small groups into a original packet. Next is authentication header. So here the authentication headers is added when the value of next header field is 51. So here authentication headers contain information that is used to verify the authenticity of the packet. So it provides data authentication, that is verification of the node that sends the packet. Data integrity, that is the verification that the packet was not modified while transmission. And anti-relay protection, that means the assurance that captured packets cannot be retransmitted and accepted as a valid data for IPv6 packet. So these are the function that is performed by the authentication header, that is data authenticity, data integrity, and the anti-relay protection. The next is encapsulating security payload. So here it contains the information used to verify the confidentiality of the packet. So it means Here it provides data confidentiality, data authentication, data integration, and the replay protection services to the encapsulated payload. And if the value of the next header field is 50, then it will contain the information about the encapsulated security payload as extension header. So this is all about the extension header that we can add to the IPv6 base IPv6 header. Next is prefix notation. So what is prefix notation? The prefix notation is a length or a prefix length that is a decimal value indicating the number of leftmost contiguous bit of the address. So here, like the prefix length is in IPv6 is expressed as an integer between 1 to 128. So here the example like 2001 colon db8 colon abcd colon 0012 double colon 0 has the prefix length that is /64. So here the /64 is giving the information about the prefix notation, and it specifies a subnet with a range of IP addresses from 000 to FFFF. So these are the range in between this particular IP address. So it represented by using the following format, like we will write the IPv6 address first, then we will write the prefix length. So as I have written here, first of all I have write the IPv6 address, then its prefix notation. So here the bold part, that is this, the portion in the bold is the network portion, whereas this part that is non-bold is defining the host portion, and it will identify an individual host on the network. So these values will goes on increasing and it will reach to the FFFF when we will define in the network. So this is about the prefix notation. Next we will discuss about the IPv6 address consists of network address, subnet address, and the device address. So these are the part of the IPv6 address. So network address are the first three grouping of numbers in the subnet mask, and these are the first 48 bits that will represent the network address. Then is subnet address. Here the fourth grouping of number in the subnet mask is the subnet address. That means the bit from 49th through 64 bits are the subnet address, whereas device addresses are the last four grouping of number in the subnet mask make the device address, that is the last 64 bits. So let's see how these are divided over the IPv6 address. So for example, the first three representing grouping of three representing the network address, that is 48 bits, then 16 bits will represent the subnet address, and after that the last 64 is representing the device address. So device address will change as on in the network, and if we are defining this address in a particular network, then it will the network address as well as the subnet address will remain same, but the device address will goes on change. The network address and the subnet address combine together to make the IPv6 prefix. So network address can also be known as routing prefix, subnet address can also be known as subnet ID, and device addresses can also be known as interface identifier. So these are the part of the IPv6 address. So this is all about the extension header and the prefix notation in IPv6. Thank you.